Hello guys, welcome to the Data Encryption Standard video tutorial. It's a difficult encryption, but if I was you, I'd have a pen and paper on at the current time and keep notes of each step, because you will be asked a question at the end of it, and it would probably be best if you kept track of all the steps. So as you can see, a lot of writing here. There's a lot to go through, guys. Basically, Data Encryption Standard is a block cipher that operates on blocks of size 64 bits, but due to the massive size of that, it's just pretty much impossible to do that by hand. So what we're going to do is something called a mini DIS, which is possible to do by hand. It's just a smaller version of the usual DIS process, so we will be able to do it by hand, but it is still a long process. So the first thing we have to do is create three keys using a binary key that's already given to us, which is 101 000 110011. Then we are given a key schedule, which are as follows. L0 is 15710 4, R0 is 6 11 8 3 and 12, and the key is 81629 4 5 10 3 7. That's the key schedule. These are given to us, by the way, guys, so if this was test conditions, all these things would be given to you, so you don't have to worry about acquiring these. So the next stage is to put the binary key given to you in order. So as we can see here, we've done that. So there's 12 binary numbers, and you just count them up to 12. And then after that, we can proceed with creating the three keys to eventually lead to the encryption. So if we look at L0, the numbers contained within it are 1, 5, 7, 10, or 4. So we look at these numbers and look at our binary key in order. So 1 equals 1, 5 equals 0, 7 equals 1, 10 equals 0, and 4 equals 0. So this gives us with 10100. So this is our L0 binary key. And then we move on after that to R0, which is 6, 11, 8, 3, and 12. Now if you repeat the process that I just showed you, this will lead to 0, 1, 1, 1, 1. So with this, we put both of them together, which creates 101 000 1111. And we use this then to create our first key called K0. But we need to put it in the order that our key schedule is given to us. So the key schedule that is given to us up here, we need to put this key in that order. So if we go down, and as you can see here, we successfully put it in that order. So the 8th bit is 1, the first bit is 1, 6th bit is 0. So it goes by this key here. So if you look at this, the 8th bit is 1 by here, and the 6th bit is 0. So that's just how it works, guys. And you just follow that, and after that, that is your K0. K0 is 1100 100 111. So it does sound quite confusing, but the further you go, the more you start to get the hang of it. But that is only K0, guys. We also got to make K1 and K2, and so to create it, we need to create L1 and R1. So to create L1, we need to move the first digit of the binary key of L0 at the end of the key and shift the rest of the digits to the left. So to show what will happen here. Now, basically 10100 will eventually become L1, as shown, which is 01001. But to get to that point, what we need to do is shift the first letter as shown all the way to the end, and then move the rest of the numbers, I should say, not letters, across left each time. So as you can see, the one at the start has went to the end, and all the other binary numbers are just shifted to the left to make our L1, which is 0, 1, 0, 0, 1. We repeat this process then to create R1. So as we know, R0 was 0, 1, 1, 1, 1. And if we just create the same shift that we just did for L0 for L1, this will then create R1, which was 1, 1, 1, 1, 0. So to create K1, we need to do what we did for K0 by joining the L and R together. So L1 and R together create 0, 1, 0, 0, 1, 1, 1, 1, 0. And we once again got to put it in the same key schedule that was given to us in the beginning, which was 816294510337. And as shown here, if we follow that, so the 8th bit is 1, so this is the 8th bit 1, the first bit is 0, so 0, 6th bit is 1, and you just keep following that, guys, and eventually you get this right here, which is 1, 0, 1, 1, 1, 0, 1, 0, 0, 1. This is your K1. So you now have K0 and K1, and now all you have to create is K2. So to create K2, we obviously need to create L2 and R2. And to do that, we use the same shift process we just used on L0 and R0, but we do it on L1 and R1 instead. So for example, L1 was 0, 1, 0, 0, 1. If we do the shifts that we just did previously, L2 becomes 1, 0, 0, 1, 0. And R1, which was 1, 1, 1, 1, 0, once you do the shift again, on that, R2 becomes 1, 1, 1, 0, 1. So we join L2 and R2 together once again, which creates 1, 0, 0, 1, 0, 1, 1, 1, 0, 1. And creating and doing the process again of following the key schedule we have, it comes to 1, 1, 1, 0, 0, 1, 0, 1, 0, 1. So now we have all three of our keys to start the encryption process, K0, K1, and K2. So now we got to go through the DES encryption process. Now this can be confusing. So it might be confusing stating it now, but when we go through the stages, you'll start to understand it a bit more. So expansion is where the message is expanded in a predefined order. So it's expanded into an order that is already given to us. Then we have key mixing, where the message is XORed with the keys generated in the key schedule. Now XORed is where it's pretty much like binary mathematics. I'll show you how it's done. It's pretty simple once you get the hang of it. Then the third phase is substitution, where the message is split in half, and it is substituted then using predefined boxes or grids. And then finally, the final stage of permutation, where the resultant message is rearranged in a predefined order, and that is probably the easiest stage out of the four. So we get past the first three stages, and then after that, the fourth one is a very easy stage. So let's begin. The expansion process, the first process. So let's say that we are encrypting A, the letter A. That's our plain text message, which in ASCII is 41H, or when converted into binary is 1000000001. If you don't know this, you can feel free to go on a binary converter. Calculators are supplied in cryptography tests, so feel free to use a calculator as well. So to start the expansion process, we basically put this binary message that we just created in order, as you can see, which is pretty basic. And then once it is in order, we can now use the expansion process, which consists of taking the last bit and placing it at the front while keeping it in its original location. So basically, to show you, this is the last bit, okay? Basically, we move this, or we duplicate it and put it at the front, but we don't remove the last bit. So as you can see, you can see it at the bottom here. You have the last bit. We duplicated it, put it at the front, but we still keep the last bit at the end. So it's not a case of completely moving it, it's more duplicating it. And the other thing we have to do to complete the expansion process is to duplicate the third bit and repeat it right next to it. So our third bit is, as you can see, 0 and 3. So if we have a look here, 0, 3, we just duplicate it, put it to the right of it, and there it is. So we followed those two processes, and this is now our expanded binary message. So we need to use this new binary message for the next stage, which is key mixing, where we have to start XORing. So basically, before going into the key mixing process, you need to know how XORing works. It's pretty basic, really. So when XORing two binary numbers, the same numbers create 0. So 0 and 0 together and 1 and 1 together create 0. While two different numbers, 0 and 1, creates 1. We'll show you in a minute anyway if you don't quite understand it. So to start, we get the binary message that we just created and put it next to the K0 key that we created earlier on. Now to XOR it, as mentioned before, two of the same numbers become 0 and two different numbers become 1. So as you can see here, we have 1 and 1, which would make 0, 1 and 1, which would make 0, and these two would also make 0, but 0 and 1 makes 1. So you guys might understand it now. So basically it comes to, let's just get rid of these a sec, and then I will show you what it comes to. But if you keep following that process, it eventually comes to 0, 0, 0, 0, 1, 0, 0, 1, 1, 0. Now as you can see, just to prove what I just showed you, two of the same numbers make 0, two different numbers make 1, which that's how basic it is. So you just need to follow that and XORing becomes very easy. Now we need to use the result from this on the K1 key and then XOR these. So as you can see, we have 0, 1, which as you guys should know now is 1, 0, 0, which is 0, 0, 1 again, which is 1. So keep following that process. The result is, as you can see, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1. So we just keep doing this process basically until we get to the end. So this result, we then XOR this result with K2 that we created. So once again, you guys should know how it works now, so I shouldn't explain it. XORing them together will result in 0, 1, 0, 1, 0, 1, 1, 0, 1, 0. So that is the end of the key mixing process, and that binary key is what we have at the end of it. And we will be taking that into the next phase, which is the substitution process. So the substitution process is where you were given two grids. They are supplied to you, you don't have to make them yourself, so you don't have to worry about that in a test condition. Given two grids, and basically the binary message that you created in the key mixing process, you have to split in half. And the first half you have to use with the left grid, and the right half, or the second half, has to be used with the right grid. So there's your left grid, and there's your right grid. So for the first half, 0, 1, 0, 1, 0, we have to make the row first. And to make the row, we have to look at the first and last digits of the first half and put them together. So the first and last digits, as you can see, is 0 and 0. 0 and 0, which in decimal is obviously 0. And then when we have to make the column, we have to look at the middle three digits, which is, as you can see right here, is 101, which in decimal format is 5. And guys, you can feel free to use any converters during this video or in the test at the end. I have no problem with it. So once we have this, we have 0 and we have 5. We then need to look at our left grid because it's the first half and follow it. So we go row 0, column 5, we go down, and as we can see, that comes to 6. So 6 then in binary is 110. So that's the first half of it. Now we need to do the second half. So our second half of our binary key was 11010. And we have to repeat the process that we just done. So we have to look at our first digit and our last digit, which is 1 and 0, and put them together. And 10 as a decimal is 2. And then we look at the 3 middle digits, which is also 101, which as we already know is 5. So on the right grid now, we look at row 2, and we look at column 5, and as we can see, that comes to 7, which in binary is 111. So what we do with these two things now, we join 110 and 111 together to make 110. Which will then be used for the final permutation stage, which is the easiest stage out of the 4. So the permutation process, basically we are given a predefined order, which we have to put the key message we've created in. What's the order that's been supplied to us is 425361. Once again, in a test condition, you will be given this, so you do not have to worry about having to acquire it. So what we do, we put our message in order to make it easier for us when we do put it in a predefined order given to us. And then we create this. So 4, as we know, 4 is 1, 2 goes here, 5 goes here, and you just keep following that, and you eventually are left with 111011, and that is our encrypted message. That is our ciphertext. We have encrypted A to create 111011. And due to all these stages, this is practically impossible to decrypt because there are so many stages to get through. Data Encryption Standard is a very secure way to secure any messages. So it is highly recommended if you want to keep a message secure to use this method, but as you just saw, it is a very long method. So, it's your turn now, guys. Do not worry, I don't expect you to create the keys all over again. I don't expect you to create your own grids. Use all the keys that we've just used, all the grids that we've just used, but all you have to do is instead of encrypting A, I want you to encrypt B. And I've also supplied what B is in binary. I want you to go through all the stages, everything I just wrote down, and you should be able to come up with the answer. You have 4 answers here that you can go through. Good luck, and I hope you do well.